Hello and welcome to our 2D game tutorial for the Unity game engine. If you've never used the Unity game engine before, this is the video for you. I would like to apologize in advance for the audio issues in this video. I just got a new audio interface and it's having some problem interfacing with the other hardware on my computer, but future videos will not have this issue. Also, all links are in the description. Let's get started. First, go to kini.nl for our assets. I'll put a link in the description. Click on Assets, type in Space Shooter, and then click on Space Shooter Redux. And click Download. It's going to ask you if you want to donate, so that's up to you. Once it's finished downloading, you need to extract all, and now let's get our background. So let's go to opengameart.org, type background space in the upper right. Let's hit search. And let's use this third thing here that says space background. Click on the name of the file to download it and go to unity.com, hover over games, click Unity Engine, and now we're going to click download Unity and select your platform here, Windows, Mac, Linux, whatever you're using, and it is going to download the Unity Hub. Once you have downloaded and installed the Unity Hub, let's open up Unity Hub. So you are going to see something like this. Click on Installs on the left, and you will see all your installed versions if you have any. Click Install Editor if you don't have one installed, and here you'll see some versions. The newest version is always at the bottom. The long-term support versions are at the top. If you're going to be releasing your game, you should always use a long-term support version unless there's some feature in the newest one that you need. So the newest long-term support is always at the top, so I'm going to click Install here. You will see a spot where you can install extra modules. For this tutorial, make sure everything is unchecked. Later, you can add any of this whenever you want. So make sure everything's unchecked, including the Visual Studio at the top, because we are going to install that manually. So click Install, and it will install the Unity engine. Once it's done, click New Project, and we are going to, up here, you can choose what version you want. Click 2D, which is the 2D template that we want to use. And choose where you want to put it. And then give it a name. So I'm going to call it Space Shooter. And then click Create Project. So let's go to visualstudio.microsoft.com/downloads to install Visual Studio 2022 Community. I highly recommend using this instead of Visual Studio Code. So click free download, wait for that to download, install it, and if you already have Visual Studio 2022, open up the Visual Studio installer and click on Modify. If you didn't have it, this is the screen that you're going to see if you're installing it for the first time. So there's a bunch of different add-ons here. The only one we need for this is the game development with Unity. Make sure that's checked. And over on the right, we want to uncheck Unity Hub, and we want to make sure IntelliCode is checked. The bottom one doesn't really matter. And then at the bottom, for me, I'd hit Modify if you already had it. If you didn't have Visual Studio, that'll say Install or something like that. So let's close that and hop into the Unity editor. Here we go. You can see over here, this is the hierarchy, and this is where all of your objects that are in your scene are located. This is the scene view where you can scroll around, pan around, and there's also the game view, which is what the game will look like when it's running, which right now is nothing. Down here, we have our project window where you can see all of the folders and all of the files that make up the game. Over here on the right is the inspector, and we will come back to that shortly. So the first thing we need to do is go to your downloads and just drag in that background image here. And also drag in that whole folder of the Kini Space Shooter Redux stuff. So first thing we should do, there's a lot of different ways you can make new objects. The first one, we're going to just click over here, right click in the hierarchy, and we're going to say create empty. And let's call this background. Here it is. If you want to see the little transform things, you can click here or hit W. And it doesn't matter where it goes for now, but let's just put it in the middle. So you can click on these ellipses over here and click reset, and it'll snap back to the middle. So now let's look at the inspector. So over here in the inspector, we have, the name of the object, some information about it. So the transform component is where it is. So you can see we can move it left to right. We can move it up and down. It changes on the Y, and don't worry about the Z since we're in 2D mode, but that pushes it away from and towards the camera technically. And of course the scale. So Unity uses this component system. So we'll click add component. And what we want is a sprite renderer. So we'll add the sprite renderer component on here. And what this does is we can drag a sprite into here and it will show that. So here we have our background down here. We'll drag this background image into there and boom, there's our background. Now that we have our background there, you can see that we have this big background, but we kind of want this to be like mobile view. So we're going to change that. So here in the aspect ratio, I don't want 16 by 9. I want 9 by 16. If you don't have that in your list here, you can click this little plus button to add a new one. You can do aspect ratio, and then you will just type in, 9 by 16 and hit OK. And you can call it something. So there we go. That's what I want. So now that we have that done, let's switch back to our scene view here. Okay, so it doesn't need to be that big. So there's a few different things we can do. We can select the scale tool and actually drag in the sides like this, right? And make it smaller like that. The other thing you can do is just over here in the side, you can, just adjust what you want it to be. So let's try like 0.4, okay, like 0.3, right? So you can change it like that. I think the easiest way to do it though, to line it up like this is just, yeah, there we go. And then we'll just drag this down. Cool. All right, so there's our background scaled down. Okay, so now we're gonna add a player. So down in the project window, open up the Kinney Space Shooter Redux folder, go to PNG, and we've got all these different ships here. These are all the player ships. Some of these enemy ships look kind of cool too. I actually don't want to use a player ship, so I'll choose one of these enemy ships. So I like this, I kind of like this one here, enemy red 1. So another thing you can do is you can just take this and drag it over here into the hierarchy. And there you go. Alternatively, you can take it and just drag it into the scene. Same thing, whichever one you prefer to do. All right, so, or we could have created an empty game object and put a sprite renderer component on it. And you can see the difference between the background and the enemy, or the player, is nothing. It has a transform, it has a sprite renderer. Okay, so, now we could rotate this around, because he's facing the wrong way. We want the player facing up. So like here's one way you can do it. You can snap him around like that. You can just go over here and type 180 on the Z-axis. However, that will change what is considered like up, because then his up will be down and his down will be up. I don't want that. So the easiest thing to do is just flip him right here. So you can flip on the X-axis and you can flip on the Y-axis. So we'll turn on flipped on the Y-axis, and now he's facing the correct direction. So we can also move him down here to the bottom of the screen, and you can click here and see kind of, where he would be. And of course, it's always a good idea to rename it. So you can rename it up here by clicking here, or alternatively, you can click over here and rename it from the left. But, that looks good. Yeah, so the player always sees the world through the camera. So 0, 0, 0 is always the center of the world, which in this case, since our camera is also in the center of the world, As you can see, our camera object here, it's just an empty game object with a transform and a camera and an audio listener on it. And yeah, it's at 0, 0, 0. So for us, 0, 0, 0 is the middle of the screen from the player's perspective when they're looking through the camera view. So you also see here that we have like unity units, right? So like what is, 1? Okay, well, you can see he moved from right here over, he moved exactly 1 unit. In Unity, by default, you're supposed to use units kind of like meters. So the physics system, it all works kind of like that. In this case, it doesn't really matter. This looks okay, but I kind of think that the scale is wrong. So over here, when we select our camera and we're in the game view, so we can see what the camera sees. Alternatively, in scene view and you click camera, you can see it down here. But if we click game view, it makes it a little bit easier to see things. So over here, we can change the size. And so look, if we go down, it's now like zoomed in more. Now we can't even see the player. So let's try 7. Okay, so I like that better. You can, the player's smaller, so we have kind of more screen space to work with, but now our background's too small. So we can go back to the scene view and you can see these white lines are showing, the bounds of the camera. So again, we can go back to the background. We can select the scale tool again and we can just drag this back out and get it to, there we go. Done. And it looks like the player can be moved down a little bit more. So we can move the player down to here. Let's see how that looks. Cool. I like that. All right. Neat. And make sure to save often as well. Okay. So right now, if we hit play, the game will run right here in the editor. Well, look, we can't do anything. We can't move. We can't shoot. And that's because we haven't actually added any behavior. To add behavior in Unity, we need to make a C# script. So let's do that right now. So it's a component, just like anything else, like a transform, like a sprite renderer, except it's a custom one that we are going to make ourselves. So there's a few different ways to do it. Actually, another thing I'm going to do here before we get too far is I'm going to go down here and I'm going to click on my assets and I'm going to add a little bit more organization in here. So I'm going to make a folder called player. I'm going to make a folder called scripts, and I'm going to make a folder called enemy. So let's click on our player. Over here, there's a few different ways we could do this. We could click add component and just start typing the name of something. And so if we type player, we can just hit new script and it will, create a new script named player. Okay, create and add. That's one way to do it. The other way we can do it is right click down here in the project window, say create C# script. We'll call it player, hit enter, wait for it to compile, and then we can click on our player and drag the player script over here into the inspector for the player. And now you can see they have this player script component. All right, let's open it up. And before we do, let's check one thing real quick. So if you edit and you go to preferences, yeah, and then on external tools, here you'll see your different installs. So if you have like Visual Studio Code or something else on here, you can change what Unity is going to use. So I want to use Visual Studio 2022, and that is really all you have to do. And you can hit regenerate project files if you want. That's probably not a bad idea to do. Double click the player script to open it. Here's our player script. It comes with these built into the top, these using statements. It's a public class called player, and it inherits from modifier. Modifier is something that every Unity game object has. So if you have a class that inherits from modifier, you will inherit all of the Unity specific methods meant for controlling your game objects that are in the scene. Let's look at these two methods here. So start is called only one time right when this object starts to exist. Update is called every frame. So if you're running at 60 frames per second, this will be called 60 times in 1 second. So we want the player to follow the mouse position. So as we move our mouse, we want the player to follow it. We can try something really cool here. So let's just say, I just want to show how this works. So we can make a debug.log here in the start method, and then we'll also make one here in the update. Okay. And let's save that. Go back to Unity. It'll compile. And we can click on the console down here, and those debug.log messages will be read out. So we hit play, and you can see, so let me pause that. You can see that it played this player spawned debug.log one time at the very beginning. And then every frame after that, you can see that it's printing out called every frame. So that just shows that start is called one time, and anything in update is called every single frame. And this collapse button, if you click this, you can see everything individually, or if it's an identical event or identical debug.log, you can collapse it and you can see it'll just show, called every frame. Over here on the right was called, 1,400 times. We'll stop playing and let's go back to our player. So we don't need these debug.log messages anymore. So what do we want to do? Well, we want our player to move with the mouse. So we need to get the position of the mouse. So we can use this built-in Unity static class called input, and there is a input.mousePosition, okay? And we want to basically just every frame, let's have it print out what the position of the mouse is. So if we save it and go back here, and we play, you will see down in the console that it is giving us the location of the mouse as we move it around. Now, we have one problem. If we want the player to move to where the mouse is, right, you can see that the mouse, the bottom left corner is 0, 0, 0. However, for our game object, 0, 0, 0 is not the bottom left corner. 0, 0, 0 would be right here in the middle of the screen. So we need to convert that screen position the mouse is using to a world position, which all of our game objects use. There's a couple ways we can do this. So the way we should do this is we will use, so this right here. And what do we want to do? We want to do it with that. So let's just put that in a debug.log statement, like so. Okay, so now what it's going to do is every single frame, it is going to take where the mouse position is and then convert that screen point to a world coordinate. So let's do it now. Let's just double check this. When we play, let's see what we get down here in the console. So now when we have our mouse in the middle of the screen, it's saying 0, 0, -10. And at the bottom, we're getting like -4, -7, -10. So we see that it has converted the screen coordinates to world space coordinates. But we don't want to just print out that. What we actually want to do is move the player each frame, right? So we can do transform.position is equal to that, okay? And what this is going to do is it's going to take the transform component on the object that this script is on, which would be our player, access the position of that, which as you can see is a vector 3. You can get it and set it. So we are setting his XY coordinates basically to match where the mouse cursor is. So let's save it, hop in the game, see what happens. So where's the player, right? You can see over in the inspector, he is moving based on where our mouse is. You can see as I move my mouse, the numbers are changing. but why can't we see him? Well, it's because his z-axis is -10. So, look, even though we're in a 2D game, watch this. If I change it back to 3D, you can see this is what's really going on. Our camera's back there. Here's our screen, and our player is right there. Everything's on this 0 on the Z, which is this blue arrow. If I move my player back to -10, which is where he was moving because of the mouse, look, he is now behind what the camera is rendering, which is this box. That's why we're not seeing the player. Also, if he's behind the background, we also won't see the player. So we need to make sure that when the mouse is looking around, the player is still visible. Switch back to 2D mode with this little button right here. Okay, cool. Let's fix that, shall we? Also, we can see the camera actually has a Z position of -10. That's why the player is going to -10, because that's where the camera is. So there's a couple things we can do. We can grab this and move it, like move the background back so the player's always on top, right? Or we can do this cool thing for 2D things. Let's switch back to 2D view. So over here, we have this order and layer for 2D stuff. It's if things are on the same plane, which they are, because they're both on the Z, like 0 on the Z, they're on the same plane. If we put, -1 to the player, he's always going to appear behind the background because the background is at 0. So we can put the player at 1, or, we could keep the player at 0, but we could put the background, at -1. And now, no matter where that player object is, even if he's back there, he's still going to be rendered on top of the background, even though he's now actually behind the background. So it's better to use the order and layer than it is to like move all your 2D stuff like, on the Z-axis. So let's go back to our script. So we know we want the player to move on the X and Y axis of the camera, but we actually don't want them to take the data from the Z-axis. So what we can do is inside update, let's define a new vector 3, and we can call it like converted position, and that is going to equal the camera.main.screen to world point. However, this time, of the input.mouse position. Okay, so all we're doing is we're grabbing this same thing from here, and we're just storing it in a variable now. Okay, so every single frame, it's going to take that and store it. What we can do is instead of moving the transform position to this every time, we're going to change what we're setting that to. Okay, we're going to set it to a new vector 3, which is the converted position.x, the converted position.y, and then 0 on the Z. Now, every single frame, it's going to take the mouse's position, convert it to world space position, and store it in a vector 3, which is just an XYZ. Right after that, immediately, again, every single frame, it's going to take the position and it's going to move it to a new vector 3, which is the X from that converted position variable, the Y from the converted position variable, but 0 on the Z axis. Okay, cool. So let's save and let's see how that works. Cool. Check it out. So our player is following the mouse. However, we don't want the player to move up and down. We only want them to move left and right. So if you move your mouse up, we do not want the player to follow that. So how can we fix that? What we can do is we can grab the previous Y position of the player. As you notice in here, as the player, if we just want them to move left and right, look, their Y position doesn't ever change. So we could just go in here and see that, okay, it's negative 6.27 or whatever you think looks good. And then we could hard code it in here, but let's not do that. Let's just up at the top here, let's just define like, a float that's y position, okay? And then in the start method, we're gonna say y position is equal to transform.position.y. So right when the game starts, it's going to take the player's y position only and store it in this y position variable. And then down here, we actually don't want it to do that, grab it from the camera. We want it to do that. So let's save and see what we have now. So now, as I move my mouse, even if it's up here, you can see the player can only move left and right. That's exactly what we wanted. So our player can't shoot. He can just move. That's not cool. All right, so let's go back to assets here. And we're going to go into this Kinney space thing. And I want to find a laser in here that I like for the player. I think blue lasers look pretty cool. Let's do laser blue 5. I like that one. So I'm going to copy it with Control C. And then I'm going to paste it in the, a copy of it in the player folder. I actually also want to do that for my player. So he was an enemy, right? He was enemy red 1. So I'm going to copy that and place him in there. I just want to have all the assets that I'm using, in the same place. So now we have a laser. Okay, well, let's take our laser and let's drag it out into the scene, kind of pretend the player just shot the laser. All right. Obviously, it's the same thing that we had with the player. If you hit play, yeah, our player is moving, but the laser is just sitting there. So we need to think to ourselves, what does a laser do? What things does a laser do? Well, the laser moves upwards. The player needs to be able to spawn the laser, and the laser can hit things. That's it. So let's first create a script for our laser. So let's show the other way to do it now. I'm actually going to rename this laser as well to player laser. And let's show you the other way. Let's do it over here. So we're going to do laser, new script, laser, create and add. It's going to create it and compile it. There it is. So the only reason I don't like doing that is because, look, now it's not in a folder, and I just like creating it in the folder that I want it to be in the first place. But whatever. All right, so now we can, double click on the script, and here it is. Here we have our laser script. So the laser doesn't follow the mouse position. We just need to modify the existing position of the laser and move it upwards. Pretty easy. So basically every frame, we just want the laser to move a little bit higher on the y-axis. That's it. So let's do this. We're going to do transform.position plus equals new vector 3. It's a float. So here we go. Every single frame, it's going to move, or it's going to set its position 0.1 on the y higher than it was before. Let's save. Let's go in here and let's watch it. So we'll hit play and boom, the laser shot up there. Okay, that was really fast. So what's the problem? Okay, well, we could just come in here and make this number lower. But we also have to remember something, that the laser is moving every single frame. Which means if you're playing on a monitor that's only 60 FPS, it's actually going to move slower than if you were playing on a monitor that was 244 FPS or whatever. We do not want it to be frame rate dependent. We don't want the gameplay to change based on the frame rate. We want it to be the same. So we're going to use something called time.delta time. So we want to multiply So we'll multiply the whole thing by time.delta time. Now, let's save it and go play it again. And what you can see now is that it is moving really, really, really slow. Because what it's doing now is it's not moving, 0.1 every frame, it's moving 0.1 meters every second. That's way too slow. Also, I don't like that this is hard-coded here. That means every single time we want to change it, we have to open the script, come in here and change this number. If you're working on a team and there's some other game designers and stuff and you just want them to be able to change it without screwing up your code, there's a pretty easy way to do that. Let's do this. So we're going to declare a new float. And let's set it to like 1 meter per second. Okay? You can do 1.0 if you want, whatever. And then obviously, we'll change this down here to laser speed. But we have a problem. If you want to change it, you still have to come in here and change this number. By default, everything in C# is private, unless you add an access modifier. So, I'll show you something cool in Unity. Let's make this public. Check this out. Now, when we click on this laser, look, over here, it's been exposed to the Unity editor. It shows our laser speed of 1. Well, now we can just change this laser speed to whatever we want. So let's play the game, and this is cool for testing too, because look, now it's at 0.5. Now let's set it to 1. Now let's set it to 3. Pretty cool, huh? So you can adjust it just from in here. And keep in mind that this will override whatever you have written here. So it doesn't really matter. You can have this, you could say, public float laser speed equals 1. You could just declare it like this and not give it a value. It doesn't matter. Over here, see, it'll just, this is what overrides that. Now, one problem though, it's generally not a good idea to make something public. If nothing else needs to know about it and nothing else needs to access it, it does not need to be public. We don't want it to be public because nothing else should be able to modify this laser speed. Nothing else needs to know about it or whatever. So there's this alternative called serialize field. What that does is it keeps it private so no other classes can access it, but it is still exposed in the Unity editor. So as a rule of thumb, if you want it exposed in the Unity editor, it should be serialize field unless you have some reason that, it needs to be public, which would be that another class has to access that value or set it or change it or whatever. So let's go back here and let's kind of find how fast we sort of want this laser to go. Let's try 5 and see what that looks like. Okay, I still think that's kind of slow. Okay, let's try 10. This might be too fast, but we'll try it out. Maybe 15. Okay, that's all right now. Cool thing is, we can easily change it anyway. All right, so now we are going to talk about something else that's very important. We're going to talk about prefabs. What is a prefab? A prefab is an object that you've created that think of it as like a parent, and you can clone instances of that prefab. So for instance, if we go here back to our player folder and we click on the laser, look, it's not even a game object. It's literally just that art, that laser art. But the laser that's here in the scene, has a transform, a sprite renderer, and a script on it that we made, and this speed that we've saved. So to stay organized, let's go ahead and make a new folder called Prefabs. And now we need two things. We need it so that the player can spawn lasers when they want to, and we don't want the laser to already be in the scene when the game starts. And what we're going to do is come down here and open our prefab folder. Then let's take this laser and let's drag it down in here. Now it's in blue. That tells you that it's a prefab. Here's our prefab. I'll show you something kind of cool here. So we have this laser in the scene, right? Its speed is 15. If we, change this to 20 on the prefab, and then look, we drag this prefab out into the scene. Look, that new one now has a speed of 20. Also, the old one has a speed of 20. Because modifying the prefab itself will modify every instance of the prefab. Alternatively, now I have two instances of the prefab, player laser and player laser 1. If I make player laser 1 20, look, so player laser is 15, player laser 1, the speed will be 20. You can also see that you can kind of tell, laser speed and 20 are like bold. Well, I can go up here and click on overrides, and I can see that this player laser script on this instance is different from the prefab. So if I hit revert all, this 20 will change back to 15, which is what the master prefab is. If I hit apply all, it will then actually change this master prefab to 20. So let's delete both lasers from the scene. We do not need those because the player needs to spawn this laser when they want to. So let's go back to the player script, because the player is the one that is going to be spawning the laser. Well, remember, the laser has this mono behavior on it, so it is a game object, right? So let's right here, let's add a serialized field, because we want it to be, we want to be able to access it and be exposed in the editor. The type is going to be game object. Let's just call it laser. All right, cool. Let's go in here, and you see what we can do is when we click on the player, we can look over here and see that there is a slot here for the laser. Well, what game object do we want to reference here? Well, it's this prefab. So we drag this prefab over into here. Alternatively, you can hit this little like bullseye thing over here, and it'll show you all of your assets, like all of your prefabs, and you can just select it from there. So now, whenever we reference this laser variable in the code, it will know it's specifically talking about that prefab. So we need to go back in here, and we want to spawn this right at, when the player presses, I don't know, let's say spacebar. So how you do this in Unity is it's instantiate, we're going to call it laser. Transform.position, again, refers to the player's position itself. And quaternion.identity means it will use the original rotation of the rotation value that the prefab has. Meaning if the player is rotated like 90 degrees to the right, the laser is still going to shoot out. It's not going to be rotated. It's not taking the rotation from the thing that's spawning it. Well, the problem with this is that if we hit play, it's just going to, every single frame, it's going to instantiate a laser. We don't want that. We want it to be when the player pushes a button, it will instantiate a laser. So we can do if input.get key, and so you can see there's this key code dot, let's do space. Okay, we'll take this and let's slap it in there. Okay, cool. Well, there's one kind of downside to this in the sense that we have hard coded this to be the space button, right? There's a better way to do this. Let's jump back into Unity. Let's go to Edit, and let's go to Project Settings. Here, there's an Input Manager. Let's click the little arrow here to show all the axes. So, look, there's already something called Fire1. Well, what is Fire1? It's just defining an input that we can refer to in code. You can also assign buttons to it. So the positive button is left control, and the alternate button is mouse 0, which is left click. So if we were to say, if the player pushes Fire1, it would be if they push left control or if they push left mouse button. Well, we want that to be space. If they hit space or if they left click. Don't worry about the gravity, dead, sensitivity, stuff like that. We can rename it. Let's call it Fire Laser. Okay. Let's jump back into our code. So we don't want to use input.get, key code space. We want to use get button down. So get button means it will return true every frame that button is held down. Get button down means it only returns true during the frame that they pushed it. And get button up is it returns true on the frame that they released it. So we want get button down, and it's going to be Fire Laser. That's what we called it. We can go back in here. And so now, if we hit play, if we press spacebar, it shoots a laser. If we left click, it shoots a laser. And you can see up here, all those lasers are spawned and just flying off into infinity up here. So awesome. So it is spawning lasers only when we want to. That is exactly what we want it to do. Okay, so I'm going to give you a challenge. All right. See if you can create the enemy by yourself. This would be, they're going to need a script to control their behavior. They're also going to need, their sprite and the game object and everything. See if you can do it. Okay, let's do it here. Okay, so let's find an enemy. So let's see. I feel like the enemies, should be, red's a good color for the enemies. So let's use player ship to red. And again, we can just drag it up in here. Okay, and we also want to flip it so it's facing, down. Cool, and I'm going to rename it enemy. This is going to be the same thing like the lasers. The enemy is not going to be in the level already, right? We want them to spawn as the level, as the game is being played. Meaning that it needs to be a prefab so that we can spawn instances of it during gameplay. So we'll drag it down in here. Cool. So now our enemy's a prefab. Again, it's in blue. So you can see that it is, a prefab. Now, if we start editing stuff on this enemy over here, like click on it in the inspector, in the hierarchy, and then over here in the inspector, it will not do anything to the parent. And then when we go to spawn new enemies, they won't have any of the behavior we put on it. Only this instance will. So I want to actually edit the prefab itself, which is this one down here in the folder. Alternatively, you can click this little arrow here. Now you're editing the actual prefab. You can also double click down here and it opens it in this isolated view. But we can just change it down here. So something we know that it has to do is it needs a script. So again, I'm going to do it the way I like to do it, which is going here to the script folders, creating a new one called enemy. And then I'll show you another way. Instead of dragging, opening up enemy and then dragging it over to the inspector, you can just take enemy and drag it either there or literally onto the enemy. So now, look, he's got an enemy script on him. But remember, he is not the prefab. If we look at our prefab here, the enemy prefab does not have the script. So you can see here that little plus means that it has something. It has a component that the prefab, parent does not. So I'll click overrides and I'll hit apply all. Now the prefab has that script as well. Alternatively, you could have just, since you already made the enemy script, you could click here on the enemy prefab, hit add component, search for it, and just add an enemy script just like that. So there's a lot of different ways to it. So now I want to edit this enemy script. So I'll double click on it over there, and here we go. Well, what does the enemy do? The enemy needs to move down. That's it. So again, I would like the game designers to be able to, do some stuff with this. So let's give them an exposed in the editor speed variable so that we can change how fast they move. And let's give it a default value. We know the lasers were moving at, 20? So equals, so we want the enemies, let's try like 10. Okay, that's going to be pretty fast. That's going to be the default value. Again, remember, if we change it in the in Unity in the inspector, it will overwrite that. So here in update, we're going to use what we did before, except this time we'll use minus equals new vector 3, 0, speed, 0, times time.delta time. Let's go in here. You can see that our instance of the enemy up here got that default value of 10 that we put in the code. We can hit play, and there he goes. He's moving down. And the cool thing about this, just like the laser, if we did put a bunch of enemies out here and hit play, they'll all move down. Great. So again, we want the enemies to not be there when the game starts. So let's just delete all enemies that are in the scene, just like we did with the laser. So we have a couple things now. So if we shoot it, with the laser, it won't die. So let's actually just show that real quick. So if we shoot him, nothing happens. The lasers just go straight through him. Okay, well, that's obviously not good. So there's no collision with the lasers, and when it does hit it, it doesn't die. And also, we don't have a way to spawn the enemies. Okay, so we have to think, where do we want to make the spawning script? Well, we can't spawn the enemies on the enemies, otherwise an enemy would spawn an enemy, and then that enemy would spawn an enemy, and that enemy was, and so on and so on. So we want a spawner, somewhere in the world, right? So earlier we created an object by right-clicking over here and, clicking create empty. You can also click this little add button over here in the upper left and say create empty. So here we go. So I'm going to call that spawner. Okay. And to be honest, it doesn't really matter where this is. We could, put it right here and say, spawn them at the position of the spawner itself. We could also put the spawner right in the dead middle of the screen and, give it values and say, spawn it at a location up here, right? It doesn't have to be on the location of the spawner. So I'm going to do it like that. Let's create a script. So I'm just going to do it over here. So spawner, new script, spawner, create an add. Okay, so we need to decide, how do we actually want to spawn enemies? Do we want to do spawn an enemy every frame? That'd be ridiculous. Spawn them every X seconds, right? Do we just want to, at the start of the game, spawn 10? So I kind of want this game to just go until the player dies. So what we want to do is we want to spawn an enemy every, X seconds. And I also want that to be, modifiable by the designer. So I am going to, right here, we're going to do, a serialized field, float, spawn rate. And, let's set the default to let's do every 2 seconds. So there's a method that we can use. It's called invoke repeating. What this does is you, as a string, you add a method name, and then you add a delay, and then how often it repeats itself. So we haven't made the method yet, but I'm going to call it spawn enemy. We want a delay of 0, meaning that right when start happens, when this method gets called, it's not going to wait to spawn an enemy. It is going to spawn one immediately when the game starts. And you know what? I actually might want that to, wait a couple seconds so the player can kind of get their bearings before enemies start spawning. So I'm going to do that. Again, we need this new method. So we'll do void spawn enemy. It's not going to take any arguments. And it's not going to return anything, which is why it's void, and it doesn't have a type. So all we want to do is instantiate enemies. Well, we need another thing up here at the top. Remember how we did with the player when we made a reference to the laser prefab. We need to do one for the enemy prefab, so we can actually tell it, what prefab to spawn. So where do we want to spawn them? We could spawn them at the location of the spawner. But, I mean, do we want all the enemies to spawn in the same place? No. We probably don't want them to all come down in a straight line, one after the other in a single file line. So we're going to want them to spawn in a few different places. We also want them to spawn off screen. But what would happen if we had them spawning, right up here, but later we decide we want the camera to be zoomed out more? Okay, well now off screen has suddenly become on screen. So we want to find a way that we can do it where if we do change aspect ratios or zoom the camera in or out or whatever, that it's still going to be off screen. So there's a way we can do this. Yeah, so we want it to spawn outside the screen and also scale no matter what the size the monitor is or the resolution or if the camera zooms out. So we want to use viewport coordinates. So now we're talking about another type of coordinates. We had screen coordinates, we had world coordinates, now we're talking about viewport coordinates. So these are pretty much percentages of the height and width of the screen. 0, 0 is the left corner of the screen. 1, 0 would be all the way to the right at the bottom. So the lower right corner, 1.5, 0 would be, 100% plus an extra 50% out to the right. So that would be off the screen, still at the bottom. So let's create some additional fields up here. Okay, so let's do, X minimum, X maximum, and Y spawn. Let's get some values for these. Okay, so we want X min to be equal to the main camera dot viewport to world point. New vector 3 like that. So we're setting X minimum. So the minimum X that it could have, which would be as far to the left, as possible. So this would be like just the very left side of the screen is going to be our minimum. Our X max is going to be the very right point of the screen. And so this would be, there we go. So again, so that's 100% to the right. So that's only defining our maximum X. And then our Y value, we want to be camera.main dot viewport to world point, new vector 3, okay, Now, viewport to world point has to take a vector 3, but remember, we only really care about the x, so that's why we're doing point x or point y. So this means that their y spawn is going to be 25% above the top of the screen, if that makes sense. So, 1 would be the top of the screen, and then 0.25 is 25% of the total height above that again. So now we can do this. So we can do, when spawn enemy is called, we want to instantiate, right, the enemy prefab. Well, where? We want to spawn it at new vector 3, 0, y spawn 0, right? And then quaternion.identity. So what this is going to do is it will make our enemy spawn centered right in the middle of the screen. However, they will be up above the top of the screen. So they will spawn where the player can't see them and move down. So let's switch back over to Unity, and we're going to click on our spawner, and we need to move this enemy prefab up here. Cool. So now it knows what to spawn. All right, so there we go. So there was a 2-second delay, and now every 2 seconds it's spawning an enemy. Of course, we still can't shoot them, and they still can't kill us when they hit us, but whatever. It is working. But we don't want them to all spawn right there in the middle of the screen, of course, which is why we made those minimum and maximum values. So let's jump back to our enemy, or our spawner script here, sorry. And inside spawn enemy, right before it spawns it, let's do a local variable inside here called random x. And it's going to be equal to this built-in thing right there. So we've got x is going to be randomly picked between, and you can see they're both inclusive, our x min and our x max. So far left side of the screen, far right side of the screen. And we will replace this 0 here with rand x. All right, let's play it. So now the game's going to start. We've got a 2-second delay, and then enemies start coming. And it looks like it's random. So they're going to be spawning in between the left edge and the right edge. Well, see, now that just happened there. That did not look good, that the enemy was spawning, with half his wing outside of the screen. Also, I think that 2-second delay is too much because they're already spawning off screen. So it already takes them like a couple seconds to be seen by the player. So I'm going to set that back to 0. I also actually want this, x min to not be, 0. I don't want him to spawn at the far edge, because that means the middle of the enemy ship is right on the edge of the screen. So exactly half of his wing, or half of him, is sticking off the screen. I do not want that. What I do want to do is, let's maybe do, so that would be like 10% from the far end. And then we could make this, so that'll be 10% from the far right. So now our enemies should not ever spawn right on that line, ever. And I also think the enemies are coming a little too slow. So again, I can click on the enemy prefab here, and let's set their speed to 15. And let's try it again. Okay, that's better. I think that looks better. I like that. So we still have a problem. The enemies can't kill the player when they hit them, and the enemies don't die when they hit a laser. So we need this laser to hit something. So again, let's go into our prefab here. Let's double click on the laser. It opens up. Well, there needs to be a collider component for it to even have collisions. So we'll click add component here, search for collider, and do not choose a 3D collider. It needs to have 2D after it. That laser is basically a capsule. So there we go, capsule collider. Bam, you can see the green outline here. I can, kind of scale it, and you can see So that green there is like the collider itself. So you can see that's pretty good. I don't even really need to change that. Okay, cool. So we can hit this little back arrow up in the upper left here. So our laser now, you can see the prefab down here, has a capsule collider on it. So the laser can now hit stuff, but the enemy does not have a collider. So nothing will happen. For a collision to occur, both things need a collider. So let's go to the enemy prefab. Again, let's just double click down here. There he is. Okay. So, collider. You know what, for him, let's try a circle collider. Okay. I think that actually looks pretty good right there. So, cool. Now our lasers have a collider, and our enemy has a collider. Let's hit play. So, what's happening? There's still no collision. We'll talk about why there's no collision after we handle this next thing, because right now we have to make a few decisions about how these collisions are actually handled. Do we want the laser to register the collision? And do we want the laser to do the work? Like, does the laser script destroy the enemy, or does the enemy script destroy the laser and itself? We also, remember, the enemy also needs to like destroy the player when they hit the player. Meaning that maybe it should be that the enemy destroys whatever it hits. Because if we put the laser destroys whatever it hits, well, as soon as the laser gets spawned, it's being spawned like inside the player, there'd be a collision and the player would kill themselves with their own laser. There's ways around that, but that's beyond the scope of this video. So let's hop back to our enemy script here. And we want the enemy to get hit. So under here, let's just do void trigger enter 2D. It takes a collider, 2D is a component, and we're going to do debug.log collision. Okay, cool. So collision here refers to the thing that it hit. Or sorry, the collider attached to the thing that it hit. Notice that we used on trigger enter. So we have to go in here. You can see the enemy. If we click on the enemy prefab here, over in the circle collider component, there's this is trigger checkbox. Well, because our script says is on trigger enter, we have to check that. So let's go to our laser, go to the capsule collider, and make that a trigger as well. There's also an on collision enter, and that will only work if this is not a trigger. But for this, we are using trigger. Let's hit play. Again, let's open up the console down here so we can actually see messages. And if a laser hits an enemy, it doesn't work. It doesn't work because for Unity to detect a collision, there has to be a rigid body component added to at least one of the things. Let's just put it on the enemy. So we're going to do rigid body 2D. Now, a rigid body component basically makes this thing a physics object. Meaning it will react to gravity, it can have a mass, drag, like all sorts of stuff. It turns it into, the physics engine will control the movement of the object. We don't really want that. I mean, we coded it so that it's just, moving down. If we were to hit play right now, which I'll do it really quick, you can see that the enemies are going to be moving, a little bit faster than they were before. And that's because not only are we pushing them down by 15 meters per second or whatever, they're also falling due to gravity as well. It's because it's a physics object, right? It has drag, it has mass, it has everything. So we have this body type here. So dynamic means that its movement is controlled by the physics engine. It can be bounced around, knocked aside, fall with gravity, there's all sorts of stuff. Kinematic means that the programmer needs to script the motion of the object, which is what we want. So let's set it on kinematic and hit play. Okay, now they're the speed we want them to be. Let's open up our console again. Cool. So my laser hit him, and you see down there it is saying, we're getting our debug.log message that there was a collision. Awesome. Well, We don't want it to just print out a debug.log. We want it to destroy some stuff. So we will use the destroy game object. So we are saying we want to destroy the game object that this script is attached to. So the enemy. The enemy is going to destroy itself. Okay. We also want to destroy the game object that the collider box that we hit is attached to. So in this case, it would be the laser. So we are grabbing a reference to the collider box on the laser that hit us, and then we are talking to the parent, game object that has that component on it, and we are destroying that as well. And it's a specific instance of this script. So when any enemy gets hit, that enemy and only that enemy is destroyed. Not all enemies, and only the laser that hit it as well. Let's hop back in here and hit play. Okay, cool. Now check that out. Laser hits an enemy, they die. Awesome. Okay, so that works. Now enemy hits a player, nothing happens still. So that's our last thing we have to fix. However, before we fix that, we should think about what all needs to happen when the player actually dies. We could have a score that shows how many enemies the player's killed. We can also have like game over show up when the player dies, whatever. Let's do the score. Okay, this is probably the hardest part of the whole tutorial because Unity's UI system is kind of a little wacky. Okay guys, sorry about that. I took a break. I've changed microphones, so it sounds a little bit different. I apologize, but let's get right back to it. Let's create a new object and call it Game Manager. Let's navigate to our scripts folder in our project browser and create the Game Manager script. So let's go ahead and grab the new Game Manager script and drag it to the Game Manager in the hierarchy. As you can see, the script is added as a component. So our Game Manager is going to be used to control everything about gameplay. The state of the game, is it game over? Has the player died? How many points does the player have? All that kind of stuff. So let's open up the Game Manager script and let's get started. Let's create an integer variable at the top here called score and give it a default value of 0. Now we need to think about what other scripts need to know about the Game Manager script. The enemy has to know about the Game Manager script to increase the score whenever an enemy is killed. So let's hop on over to the enemy script and give it a reference to the Game Manager. So let's create a serialized field up at the top, and the data type that it's going to be is Game Manager, and we'll just call it Manager. So here we have our reference to the Game Manager. Let's hop back into Unity. You can see here that when we click on the enemy, there's a slot here for a Game Manager. We'll try to drag it, and you see we can't. The reason why is because you can't drag something that's already in the scene, like over in the hierarchy, into a prefab. If the enemy was already in the scene like this, yeah, sure, you can drag the Game Manager over and just put it there. But that's not the case here because our enemies do not exist at the start of the game. So we need a way that the enemy prefab knows about the Game Manager without being in the scene at the start of the game. So let's hop back into our Game Manager script and I will show you exactly one way to do that. So the first thing, well, let's just get this out of the way. Let's add a public method here called increase score that is going to take an integer as an argument, and all it does is it increases the score by whatever amount is passed in. It has to be public because we are going to want the enemy or anything else to be able to increase the score. So now we are going to do one of the most controversial things that you can do in game development and make something called a singleton. So let's do that right now and I'll explain it as we do it. So we are going to create a public static Game Manager called instance. So notice that we're basically creating a static instance of the game manager that can be called from anywhere and also doesn't need to be instantiated. Well, the whole point of a singleton is that only one instance of it exists. So let's use the awake method here, which is called before start, one time, just like start, but it happens first. And we are going to say that the static game manager instance is actually this, meaning this script or this instance of this script. So essentially, this ensures that there's only one single instance of the static game manager in our game. So let's hop back to our enemy script here, and we are going to call the increase score method from the game manager that we called instance. And let's do 10. So let's hop back to our game manager script, and I want to point something out and show you something kind of cool that you can do in Unity. So as you can see here, our score variable is not serialized field and it's not public, which means it is private, which means it will not show up in the inspector. And so the only way we could make sure that the score is actually incrementing and working inside Unity is if we use the debug.log. But I'm going to show you another cool trick. So let's go back to Unity, and if you click on these little ellipses over here at the very top right of the inspector, you can go here into debug mode. And look, now it shows even private variables over there. So let's hit play. And let's kill some enemies. So as you can see, the score is working. Every time we kill an enemy, our score is going up by 10. So we know it's working, but our player has no idea that it's working. There's no way that they can see what the score is while they're playing the game. So we have to add a user interface to make it so the player can actually see what their score is and know that they're actually getting rewarded for killing enemies. So let's right click in the hierarchy, go to UI, text Mesh Pro, and this little window here might pop up. Click on import TMP Essentials, and once that's done, just close that little box. So you can see this did a few things. Over here in the hierarchy, it created a canvas, this event system, and the text Mesh Pro, which is a child of the canvas, which is the thing that we actually wanted to make. So let's click on the canvas and hit F on the keyboard, which will zoom out to fill the whole scene view with the game object that you have selected. So you can see that like the game's in the bottom left corner. That just makes it so it's easier to edit the UI and stuff without it being all over in the way of your game objects that you are trying to manipulate in the scene. So you can see that new text is down here in the bottom left of the canvas, and it's also hanging off the side a little bit. And when we enter the game view, you can see that in the game view, new text is also down at the bottom left and hanging off the side a little bit. So how it looks in relation to the canvas is what it's going to look like on the game screen. So if we move it over like this, you can see that it's moved over in the game view as well. One other thing I want to mention is that whenever you're using UI components, you should actually use this rect tool over here on the toolbar, not the normal move tool or scale tool or whatever. It helps it snap and you can rearrange things better. It's just way easier. One of the most important things to remember when you work on UIs is on this canvas object, don't forget to do this or it'll screw up everything. Select your canvas, go over here to UI scale mode under the canvas scaler component and set that to scale with screen size. And you can set your reference size 1920 by 1080. I'm just going to leave it on 800, 600. If you don't do that, the game will look different and the UI will look different on everybody's screen depending on what the resolution and the aspect ratio is and stuff. So doing this ensures that the UI looks consistent on everybody's screen and there's no stretching and nothing gets cut off. So let's go to our text object here, and let's change this from new text to what we actually want it to say, which would be score, colon, space, 0. That's obviously what the score is going to start at. So we'll just leave it right there for right now. And we want to move it to the place that we actually want it to show. So I'm going to drag it up into the upper left here. And you can see, there it is in the game view. So what we want to do now is anchor this to the upper left corner. Basically, it's just giving the UI some more information on where we want this. So you click on this little target thing over here in the inspector and set it to upper left. And you can also notice you can hold Shift or you can hold Alt to set the position or to also set the pivot. Now, I don't want to set the pivot, but I do want to set the position to be in the upper left. So as you can see, I'll set the pivot real quick and you can see what it does. It'd make it so if you rotated it, it rotates on that upper left corner, but we don't want that. So I'm going to undo that and put it back to the middle. But I am going to hold Alt and click in the left corner so it moves up there to the upper left corner. And basically the point of doing this is just letting the UI know that's where it's supposed to be. We also have more fine control over exactly where it is. So notice now the position X and Y says 0, 0. So let's just move it 25 pixels out to the side and then 25 pixels down. And so now the spacing between the top and the left side of the screen are the same, and I like how that looks. So to update this score while we're playing the game, we need the game manager to have a reference to this text object so that it can modify the text at runtime as enemies are killed and the score changes. So let's hop back in here to the game manager script, and we are going to add a serialized field, text mesh pro UGUI. You notice it also automatically adds a using TM Pro statement up here at the top. And as you can see, we called it score text. So now we have a spot where we can reference that. Down here in the increase score method, after the score is actually increased, we want to modify the value of score text to equal the new score after it's been updated. So we'll use score text.text is equal to score.toString. So that takes the score, which is an integer, and converts it to a string so that it can be displayed in this TextMesh Pro object. I want to show you something we could have done. We could have made this, instead of a TextMesh Pro object, a game object. But look, now our score text.text doesn't work. So we'd have to use score text.get. Well, let me just erase that. We'll have to use score text.get component with these little less than equal than sign, TextMesh Pro UGUI, because that's the type of component we want to access on the game object score text. Then we have to access a .text variable, and then we can finally set it to score.toString. So that's another way to do it if we would have just made it a game object. But as you saw before, it's way less stuff to type if we just make it a TextMesh Pro object from the get-go instead of a game object. So let's just get rid of all of this, and let's switch this back to a TextMesh Pro UGUI object. And down here, we are going to do score text.text equals score.toString. And actually, that's not quite right. We don't want it to just show the score. We want it to show the word score, and then after that, show what the score actually is. So we're going to put in parentheses, score, colon, make sure you add the space, another parenthesis, and then we're going to add the score. This is how you concatenate strings, and so C# will let you use an integer and a string, and it will automatically convert that integer to a string and display the correct string that we want. So let's hop back into Unity. Let's select our game manager. And remember, we have to drag this TextMesh Pro object over into that field so that it knows what text it's supposed to be modifying. I'm just going to rename this real quick. I do want to point something out. If you ever hit play and down in the console you get a red error that says null reference exception. It means that you tried to reference a script or a game object or something like that that doesn't exist. Even veteran Unity programmers make this mistake because they didn't drag the thing from the hierarchy into the field on the right on the inspector. There's other things that can cause these null reference exceptions, but that is a very common one. So if you are seeing that in yours, make sure everything that we've made a serialized field to reference, you've dragged it from the hierarchy to the inspector. All right, let's hit play and check this out. Cool. When we kill an enemy, the score goes up by 10 each time. And you can see that reflected in the score UI in the upper left. Awesome. Great. So what's going on behind the scenes here are that when an enemy dies, it is calling the increase score method on the game object. So now let's go back to our problem that we had earlier, which is that, let's hit play. When the player gets hit by an enemy, they don't die. Nothing happens at all. Well, what do we want to happen? We want the enemy that hit the player to die. We want the player to die. And let's say we want game over to appear on the screen. So let's select our player object. And as we saw before, it has to have a collider on it to register collisions. Also, notice we haven't made our player a prefab. We don't have to in this game because there's only one of him. But let's say, I don't know, you have multiple lives, like when you die, you despawn and then you come back a couple times. So it's probably actually a really good habit to just make the player a prefab, even if you don't actually need to. But let's just go ahead and make him a prefab. So let's, from the hierarchy, just drag the player down to the prefab folder. There we go. No problem. So we can select the prefab down in the project window, go over to add component, and give him a circle collider 2D. Let's double click on the prefab in the project window. It opens it up in this zoomed in view. And we can change the radius or whatever. And so let's make it a little smaller so the player is actually a little harder to hit, so they feel like they're better than they actually are. And hit the little arrow at the upper left to back out of that. Okay, so remember our enemies already have a rigid body, so the collision should just work because one has a rigid body and both have colliders. So let's hit play here and check it out. There we go. Cool. It works. When the player gets hit by an enemy, they both get destroyed. We can see here in the enemy script, remember we already have it destroying whatever game object it hits. So in this case, it was the player, so the player is going to get destroyed. But we don't want it to only destroy the player. We want it to also trigger a game over. But we can't just put, right there in the onTrigger enter 2D method in the game, because right now it's not checking to see what it hit. It's just saying if you hit something, destroy it. So if we put in the game in there right now, it would end the game when a laser hit the enemy. It would end the game if an enemy hit another enemy. So we need to add some condition in there to check if it's the player. But before we do that, let's head back to the game manager script and we're going to add a Boolean called isGameOver and set it to false. A Boolean only stores a true or false value. And obviously when the game starts, isGameOver is going to be false because the player hasn't lost the game yet. Let's also make a public method down here that ends the game, because we want the enemy to be able to call this whenever it hits the player and destroys them. So the logic for our initiate game over method is actually pretty simple. The only thing that it'll do is set the isGameOver Boolean to true. That's it. So let's hop back into the Unity editor here. And what we want to do is add the game over text. So click on your canvas in the hierarchy. We're going to right click, so it'll make it a child of this. And we're going to go to UI and do another text mesh pro object. Let's call this one game over text. And let's modify it the way that we want to. So remember, you can hit F to zoom out when you have canvas selected. Let's change the text to game over. And it's already right in the center of the screen. So let's just make it a little bit bigger. Select the rect tool. And I like stretching it all the way out and then centering it again, just to make sure it's perfectly in the center. And just another slight adjustment here, and it'll snap right to the perfect center of the game screen. Check it out in the game view. Looks great. Okay, right now we have a problem. If we started the game, game over is going to be displayed right in the middle of the screen. Obviously, we don't want that to be the case. We only want game over to show when the players lost the game. So we need it to be invisible when the game starts and only become visible once game over has been triggered. So at the top of the inspector up here, right next to the name of the game object, you see this little checkbox. Let's check that off, and it will make game over disappear. The game object's still in your game, it's still in your scene, it's just not enabled. So when the player starts the game, it doesn't show. If you flip the checkbox back on, you can see game over. So obviously we want it disabled right now because we don't want it to be shown when the game starts. So let's pop back over to our game manager script, and we need to create a reference for the game over text the same way we did with the score text. Because when the player's playing the game, we want to modify that game over text at runtime. Notice that our new reference is of type GameObject, not TextMeshPro GUI. That's because the GameObject is what we want to disable or enable, not the TextMeshPro UGI component that's on the GameObject. So we want to do it here in initiate game over. After it flips the is game over boolean to true, right under that, what we want to do is make the game over screen show up. And to make the game over screen show up, all we have to do is enable the game object text that we had disabled. So it's going to be game over text dot set active true. And remember that little checkbox we checked to make it visible or invisible earlier? This is just checking that checkbox again. So now let's get back to the enemy script and handle the problem that we had before, where the enemy is not checking to see who it hit. We need it to check to see if the thing that it hit is the player, and only trigger the game over when it's the player that's been hit, and when it hits a laser, it will increase the score. So we can do this if collision.gameObject.tag is equal to player. What this does is when something hits the enemy, it will look at the game object of the collider box that hit it and check its tag. If the game object's tag is player, then we will destroy the enemy, destroy the player, and trigger the end of the game. If it was a laser, it'll only destroy the enemy and destroy the laser. So the same way that we increase the score, we will do game manager dot instance, but this time we will do dot initiate game over. So just to recap, if it is the player, it's going to call initiate game over, and if it's not the player, it's going to increase the score. So we'll put that in the else statement. The bottom, the destroy game object and destroy collision.gameObject, it'll do no matter what. So we'll leave that outside of the if else statement. So let's hop back into Unity here. And don't forget, select the game manager, and we need to drag that game over text over there into the field in the inspector so that it knows what that reference is referring to. So remember, we had it set up so that when something hits the enemy, it's checking the tag of the game object that hit it. So we need the player to have the player tag. So let's add that on them now. So go in the upper right of the inspector, you'll see this thing that says tag with the drop down menu. And look, there's already one called player. So click player. And if you did need to add a new one, this is how you would do it. You'd click the plus button, give it a name, and save it. But player is already there, so we'll just select player. All right, let's hit play, and we can test out all the new stuff that we did. So let's shoot an enemy first to make sure that's still working. Yep, and an enemy hit us. Cool, game over. It works. And then enemies just start going down the screen forever. So right now, if you lost and you wanted to replay it, you'd have to completely exit the game and then restart it again. Let's make a way that after the player dies, they can quickly restart the game and try again. So we'll do this by reloading the scene. So let's go back to our game manager script, and we need to put in the update method because we need to check for player input all the time, every frame. We're basically going to be listening for a key press to restart the game. So just how we did clicking input earlier, we'll do if input.get button down, and let's use submit, which is enter. So if they press the enter button on that frame, then everything inside this if statement here will be called. And the thing we want to do is restart the scene. So we'll use this built-in class in Unity called Scene Manager. Notice how it automatically added this using statement up the top, Unity engine.scene management. If for some reason yours doesn't automatically do that, just type that up there manually so that this part we're doing will actually work. So it's scene manager.load scene. Well, what scene? We want to load the current scene, the only scene in the case of this game. So there's a quick way to get that. It's just scene manager.getActiveScene.name. That's it. And that's because this load scene takes in a string, which is the name of the scene. And so we're passing in the name of the active scene. So let's go back to Unity. And one thing I want to do is I want to double check that submit is actually an input. So let's go to Edit, Project Settings, and look at the input manager here. And look, there's submit. So there's two buttons called submit. What are they? So it's return, joystick button 0, enter, and space. Well, we only want it to be enter. So let's remove space, because remember we use that for shooting. So if we don't do this, it'll actually shoot a laser when you hit enter. And we don't need joystick button 0 either. So enter and return, let's just leave them on those. And there we go, we can close that. So let's hit play and see how this works. So right now I'm pressing enter, and look, it's restarting the scene. Well, we don't want it to reset the scene every time you press enter. We want it to only reset the scene when you press enter after you've already died. So let's go back to our game manager and add these double ampersands, which mean and. So the condition on the left and the condition on the right need to both be true for any of the logic inside this if statement to be called. So now, if they push the enter button, and if and only if the game is also over, only then will it restart the game. Let's go back to Unity. Let's click play. And I'm just going to start hitting enter a bunch like I did before. And look, it's fixed. Hitting enter is not doing anything. So let's die. And now, if I hit enter, it restarts. So we've made a player. He follows the mouse. He shoots when you click. When you kill an enemy, the score goes up. When an enemy hits the player will die. And after you've died, you can press enter to restart the game. Thank you so much for watching. If you like this video, please like and subscribe to our channel. It helps us put out new videos. I apologize for the audio issues. I will have those fixed in the next videos. Also, don't forget to turn on all notifications so you don't miss anything in the future. See you next time.